Hey everyone, this is Muhammad Nadeem and welcome to my YouTube channel. Today in this video, we will discuss that what is capacitor and what does mean by capacitance of the capacitor. So let's start the video with the simulation. So here we have the capacitor as we discussed in the previous videos as well. Now this is actually the parallel plate capacitor which consists of two plates. One is this upper plate and this is the upper plate and the lower and the other one is this lower plate, and these two plates are separated by a distance d, and the upper plate is connected through this wire to the positive terminal of the battery, and this lower plate is connected through this wire to the negative terminal of the battery. Now when I on the battery, the large number of positive charges will appear on the upper plate, and as we know that when there is a charge, there will be electric field lines originating from that charge. In this case, large number of electric field lines will originate from these positive charges, and when electric field lines which come from these positive plates, when it interact with the lower plate, as the lower plate is usually a metal, and metal have large number of atoms, and inside the atom we have protons and electrons, and when the electric field lines come from the upper plate interact with the lower plate, the electrons in the atoms of this plate will come to the upper surface of this metal. So in this way, the lower plate is also charged, but with opposite sign. So the large number of electrons are come to the upper surface of this lower plate, and this process is called electrostatic induction. Electrostatic induction. Electrostatic induction is the process in which the charges appear on the other body when the field of the first body interact with that. When I disconnect the battery from here, the charge is still present on these plates. They do not neutralize. Why this? This because the number of electric field lines still originating from these positive charge and terminate on these negative charges, which are these. So there are large number of electric field lines present between these two plates, which is used to which is used for the attraction of these charges, these positive charges and these negative charges, and therefore they are held by these electric field lines. So due to the interaction between these positive and negative charges, these charges are still present on these positive plates even if I disconnect the battery. So this is all about the capacitor. So from this discussion, I can conclude that capacitor is actually capacitor is the device, a device which store electrical charges. So this all about the capacitor. Now we are going toward the capacitance of the capacitor. So capacitance of the capacitor is actually the capability of the capacitor to store the charges. Here in this simulation we have the same setup, and if if I increase the voltage of the battery, some charges will appear here. So in this case, less number of charges are present here, and now the voltage between these two plates are measured by this meter by connecting these two terminals to each capacitor. Now it shows that 0.26 volt is present between these two plates. So if I increase the current, this voltage will also increase. So please focus here and here as well. This charges will increase if I provide the more potential from the battery, due to which this potential will increase. So Now this is 0.86 for these charges, and if I increase these charges further, this will increase from 0.8 to 1.5 here. So from this relation I can write it is the from the previous relation I can write is Q is the charges directly proportional to the voltage. If I increase the Q, the voltage also increase. So here is the proportionality, direct proportional sign. In order to replace this proportional sign, we will put equal and constant instead of this proportional sign, and this will come its own place. So here instead of constant I write C, which is also a constant, and this is V. And from this equation we can say that C is equal to Q by V. So this is actually the capacitance of the capacitor. So from this relation I can define the capacitance of the capacitor is capacitance of the capacitor is this is actually the capacitance which is actually the magnitude of the charges on the plates of the capacitor divided by the potential difference between the plates. So the capacitance from the above equation is written as the magnitude of the charges on the plate, magnitude of charges on the plates divided by the potential difference, potential difference between the plates, potential difference between plates. So this is called capacitance of the capacitor. So from here I can also define the capacitance of the capacitor is this capacitance of the capacitor is defined as the capacitance is defined as the ability or the capability of the capacitor to store electrical charges. So this is actually the ability of capacitor to store electrical charges. So this is the capacitance of the capacitor. Now this is the formula for the capacitance of the capacitor. Now we are going to generalize, to specify this formula to the parallel plate capacitor. So the same formula for the parallel plate capacitor is given as, so for the parallel plate capacitor I can write it as in order to find the capacitance for parallel plate capacitor, we know the formula, which is the electric we know the formula, which is the electric potential, electric field between the strength of electric field between the plates of the capacitor is given by E is equal to the negative gradient of the potential. This is the strength of electric field present between the plates. So from here the above is this is actually potential difference, which is given by V2 minus V1 and divided by del R. In this case, this del R is actually the distance between these two plates, which is actually D. So from that I can write here D. V2 is the potential on the negative plate and V1 is the potential on the positive plate. Therefore, the potential difference between these two plates is given by V2 minus V1. V2 minus V1. So I write that here. So this is V2 minus V1. So this E this E is the actually the strength of electric field between the two plates is given by minus V2 minus V1. So here in this case it become V1 minus V2 divided by D, and this V1 minus V2 is equal to V, so this become V by D. So here the V1 minus V2 is equal to V. This is the equation 1. Now, from the Gauss law, the electric field intensity between the plates, is given by the Gauss law, can be written as, which is E is equal to the sigma by epsilon naught. So this is the equation 2, which is given by the Gauss law. So here this sigma is actually the charge density on the plates. Here on this plate there is not a single charge, but there is large number of charges. So here the concept of the charge density come into picture, and which is given by this relation. So the charge density is represented by this, which is equal to the number of charges present per area. So charges per unit area. This is equation 3. Now put equation 3 in equation 2. Then equation 2 become this. So here the equation 2 is E is equal to sigma. Instead of sigma, I will put this Q by A and divided by epsilon naught. So now this is equation 4. So the right side of equation 4 and equation 1 is this. The left side of the equation 4 and equation 1 is the same. Comparing equation 1 and 2, equation 1 and 4, we can write as the left side of these two, the equation 1 and equation 4 is same. Therefore, the right side of these equation also be same. So here the right side is Q by A epsilon naught, and which is equal to the right side of the equation 1, which is V by D. So from here I can find Q is equal to Q is equal to A epsilon naught V divided by D. So this is the equation 5. Now put the equation 5 in this equation A. This is equation A. So then we will find the capacitance for the parallel plate capacitor. So the equation A become here this equation A become C is equal to Q. Instead of that Q, I will put this A epsilon naught V divided by D. Instead of Q, I put this, and divided by V come at its own position. So here this V will cancel with this V, and this equation become C is equal to A epsilon naught divided by D. So this is the capacitance of the capacitor. This is the capacitance of the parallel plate capacitance in vacuum. So this is C vacuum, C in vacuum. Now this is the relation for the capacitance of the capacitor for the vacuum. So generalize this for the medium. So for the medium, the relative permittivity is defined as the permittivity of the medium divided by the permittivity of free space. So from here I can determine the permittivity of the medium is epsilon naught epsilon r, and this is equation 6. So here this is for the vacuum. This is for vacuum. Now this equation, let say this equation, this is equation for the medium is given is. So this equation for the medium is given by A epsilon. Epsilon is actually the permittivity in the medium divided by D. So instead of this epsilon, I will put this, which is equal to A is this, and instead of this epsilon, I will put epsilon naught epsilon r divided by D. Now rearrange this equation. So C of medium is equal to A epsilon naught divided by D multiply epsilon r. So this A epsilon naught divided by D is actually this equation. So instead of A epsilon naught divided by D, I can write C vacuum. So this equation now become this. So C of medium become C vacuum. So instead of this, I will write C vacuum multiply relative permittivity. This. So this is the capacitance of the capacitor for the medium. So these all are the calculation for the capacitance of the capacitor for the parallel plate capacitor. So this is the calculation for the capacitance of the parallel plate capacitor. First, I write the strength of electric field between the two plates and write the formula for that. And similarly, that strength is also given by the Gauss law, which is this. And the left side of these two are same, so I compare the right side of this equation and it gives us the Q value, and then I put the Q value here, then it gives us the capacitance of the parallel plate capacitor, which in vacuum. So then this is only for vacuum. If I put the medium between these two plates, so this if I put this medium between the two plates, so now the capacitance for this capacitor is given by this equation, which is equal to the C. Now the capacitance C medium mean now I insert the medium between the plates of the capacitor. So for this the capacitance will be equal to the capacitance when there was no medium. So the capacitance in vacuum multiply the epsilon r. So here this epsilon r is called relative permittivity, and for every material this relative permittivity is different. So if we find if we put the material which have high relative permittivity, then the capacitance of that capacitor will be more, because the larger factor will multiply with the capacitance of the vacuum, and therefore the capacitance of the medium will be high. So this ER is different for different material. We have this table. In this table, this is actually the substance. So for vacuum, and this is the ER epsilon r, and the epsilon r we call relative permittivity, and the other name for the relative permittivity is also a dielectric constant. So this is actually the ER. So here this is the ER. So for vacuum, ER is 1, epsilon r is 1, and for air the epsilon r is 1.00054, and for the glass the epsilon r is from 5 to 10, and in this way every material have its own epsilon r value. So in order to find the capacitance for the medium, we will multiply the epsilon r value of that material that we are going to put between the plates with the original capacitance. So here was the explanation about that. Now at last I am going to discuss the unit of the capacitor, which is actually a farad. So the unit of the capacitor is given by the unit of capacitance. The unit of capacitance is farad. So here the unit of the capacitor is farad, and one farad is equal to 1 farad when 1 coulomb charges are present on the plates of the capacitor, and when the potential difference between the plates of the capacitor is 1, then the capacitance in that case will be 1 farad. So here if the charges on the plates is are 1 coulomb, and the potential difference between the plates is 1 volt, then this will be called the farad, and farad is the unit of the capacitance. So that's all about today video, and that's it guys. Thanks for watching.